Given the feedback system shown below oscillates at 2 radian per second. When the options are given are k equal to 2 and a equal to 0.75, k equal to 3 and a equal to 0.75, k equal to 4 and a equal to 0.5, k equal to 2 and a equal to 0.5. He has given a control system and he is asking for what values of k and a. Here there are some variables. This whole system oscillates at 2 radian per second. This is a standard question from RH criteria, right? First of all, find what is y of s by r of s. That is closed loop gain. What is y of s by r of s? G of s by 1 plus g of s. Why? See, general feedback loop I am drawing. G of s and h of s are there. H of s is the feedback and g of s is the forward path gain. From the control system basic, what do we have? Y of s by r of s is equal to g of s by 1 plus g of s into h of s. Okay, this is what we know. Here h of s is 1. Therefore, g of s by 1 plus g of s h of s, that is k into s plus 1 by s cube plus as square plus 2s plus 1 plus k into s plus 1. When you simplify this whole one, g by 1 plus gh, then you will arrive at this. Or the simple technique for this is, whenever you have a closed loop transfer function with unity feedback gain, that is one feedback gain, and it is a negative feedback, then you can write directly k by this g of s and take the numerator to denominator directly. That is a technique. Or you do g by 1 plus gh, whatever you feel. Okay. Finally you will arrive this one only. I am writing y of s by r of s again in a simplified manner. I separated all the s cube, s square, s and constant terms. Therefore finally you got this. So from the RH criteria, what does it say? The poles. These are the poles. Okay. I am using RH criteria, which says make a Routh-Hurwitz table, that is s cube, s square, s power 1 and s power 0, and write these. 1 is the coefficient of s cube, then for s coefficient 2 plus k here. Next write coefficient of s square here, a alternate coefficients, then again k plus 1. This is what the rule says, right? And what will s power 1 be? This into this minus this into this by a. Therefore 2 plus k into a minus k plus 1 by a. I can write this here, 2 plus k into a minus k plus 1 by a. This is this term, and here it is 0 anyway, the second term. And here what is this one? A into 0 minus this into this by whole this one, which gives k plus 1. You can directly drop it here. The last term can be directly dropped to here. This into this minus a into this one. First you should do this one. From here you should start, from the lower one. Therefore it is k plus 1. Okay, when does a system oscillate? Only when one whole row becomes 0, right? Therefore here one whole row becomes 0, and that too it should be an odd. And so s power 1 should become row of zeros, which can be 2 plus k into a minus k plus 1 by whole a is equal to 0. I am just applying the rule. The rule says that if a row of zeros occur in RH criteria, whole row zeros, then we have oscillations. It says oscillations are there. Therefore 2 plus k into a is equal to k plus 1. If this is satisfied, then the system is oscillating. Okay, when system is oscillating, what is the frequency of oscillations? That is given by auxiliary equation. How do you write the auxiliary equation? From the above row of the row of zeros, that is this s square row, that is auxiliary equation. Auxiliary equation, I am writing it here. What is auxiliary equation? As square plus k plus 1 is the auxiliary equation. Okay. How do you get the frequency of oscillations? Substitute s by j omega, that is a into j omega whole square is minus omega square is equal to minus k minus 1, since I am taking it this side. Therefore a omega square is equal to k plus 1, omega equal to k plus 1 by a whole root. This is the frequency of oscillations. And what has he given? The frequency of oscillation should be 2, omega equal to 2. 2 is equal to square root of k plus 1 by a. Therefore what do I have? 4 equal to 4 into a is equal to k plus 1. Substitute it here. 2 plus k into a is equal to 4a. Therefore k is equal to how much? 2. When k equal to 2, a is equal to 3 by 4, that is 0.75. K is 2 and a is 0.75. Therefore a is the correct option. Okay. What did I do? He has given this and it oscillates at 2 radian per second. Therefore you can directly say this is a question on RH criteria. In RH criteria you should draw Routh-Hurwitz table. Therefore I drew it. And whenever a row of zeros occur, the system oscillates. That we know. Therefore I have equated this to 0 and I found out. Okay.